You know, today we're going to talk about a hidden hero of the modern world. It's a material that's so strong it's used in the heart of a jet engine, but at the same time, it's so safe that it can be placed right inside the human body. Okay, so let's jump right in with a question for you. What if I told you there's a metal out there with all the muscle of steel, but it's nearly half the weight? I mean, it sounds like something straight out of science fiction, right? But I promise you, it is very, very real.
The answer, of course, is titanium. And look, this isn't just some random element you memorize from the periodic table in school. No, this is a material that has seriously earned its title as a supermetal, and for some pretty amazing reasons.
It's become absolutely essential for those high-stakes industries where, failure just isn't an option. So let's dig in and figure out what makes this unique metal so critical to our most advanced, most demanding technologies. So what is it that really makes titanium so special? What's its secret sauce? What gives it these incredible, almost comic book level superpowers? Well, let's break down its core properties. It all really comes down to this unique trio of traits. First, that incredible strength to weight ratio. Second, it's just amazingly resistant to corrosion. I mean, it basically laughs at rust, even in harsh salt water. And third, a quality called biocompatibility, which, as we're about to see, is a complete game changer. Let's put this into perspective so it really clicks. Steel gives you all the strength you could want, but it comes with a pretty big penalty. It's heavy. Titanium gives you that exact same power, but at a fraction of the weight. Now, if you're an engineer designing an airplane, that changes everything. It means you burn less fuel, you can fly farther, and you get better performance. And then you have its other superpower, biocompatibility. So what does that actually mean? Well, to put it simply, our bodies don't fight it. They don't see it as an invader, it's not toxic, so our own living tissue can just coexist with it peacefully. This one property alone opens up a whole world of unbelievable medical possibilities. But here's where it gets really interesting. Pure titanium, the stuff that comes out of the ground, it's really just the starting point. To unlock its true potential for all these crazy applications, it has to be totally transformed through a pretty intense engineering process. Yeah, we're talking about taking a raw element and turning it into a custom-built, high-tech material. The process is called alloying, and it's less about finding the perfect material and more about designing it, practically atom by atom. The whole thing is kind of like a high-tech recipe for a master chef. You start with your base ingredient, pure titanium. Then you carefully mix in other elements, maybe a little aluminum, a dash of vanadium, to bring out specific properties. Then you cook it all together in a super hot vacuum furnace. And what comes out is a brand new creation, a specialized titanium alloy, custom made for a specific job. And listen, this isn't just about making the metal stronger in general. This is about precision. It's about designing and building an architecture of strength for very, very specific and very high-stakes jobs. For example, if you need something for a fan blade inside a jet engine, you'll whip up an alloy that can handle insane temperatures and unimaginable stress. But if you need a material for a prosthetic limb, well, that's a whole different recipe. You'll engineer an alloy that still has that amazing strength, but this time you're combining it with perfect biocompatibility. So, we've covered the why and the how. Now let's get to the really cool part, the what. Let's look at the real-world places where these incredibly engineered materials are making all the difference. In the world of aerospace, titanium wasn't just an improvement, it was an absolute revolution. That killer combo of strength and low weight is critical for things like jet engine parts and the skeletons of airplanes. It allows us to build engines that are more powerful, way more fuel efficient, and just fundamentally safer than ever before. And then in medicine, its impact is just as massive. Because of that biocompatibility we keep talking about, these strong, lightweight alloys are used to create incredible things like advanced prosthetic limbs and medical implants. We're literally talking about rebuilding the human body, giving people a quality of life that just wasn't even possible a few decades ago. So when you put it all together, the conclusion is pretty clear. From the jet streaking across our skies to the implants that are healing our bodies, our modern world would look completely different without titanium. It really is an irreplaceable metal. So that's titanium for you, the super metal hiding in plain sight. It really makes you wonder, doesn't it? If titanium was the material that defined so much of our recent past, what new material is out there right now, just waiting to define our future?